So there's another theory which was launched, it was believed before this, and that theory is called the wave theory. So you can write that. In wave theory, in wave theory, basically it is said that electrons can be emitted from any source as long as light is incident as long as light is incident onto it. So it's not like only UV can do it or some other way. They're just saying that any light can do that, first of all. The second thing it believes in is that the light has a continuous nature of energy. So basically, what they're saying is that it doesn't carry photons, just a wave with that has energy that can be transmitted. And because of this, we can say which is accumulated which is accumulated by electrons till they have enough energy to release. So it's like they're saying when the light falls, the electrons will continue to gain energy, and when they have enough energy, they will release from the metal. And it's not like only one photon, it's not a one-to-one relationship, it can continue to do that. All right, so it's completely different from the photoelectric effect. This theory was basically debunked by a scientist later on, de Broglie and Einstein as well. So you're going to learn about that. But sometimes in the exam, they're going to ask you how wave theory is different than that. So you guys can write this down. Now, with that said, Einstein had to verify the equation that we have just made yesterday, which was kinetic energy is proportional to the frequency of incident wave minus the threshold frequency of the metal. All right, kids. Zainab, did you get the chance to view the recording?
No, sir.
That's very bad because today
Sir,
it
where
will
do I find it from?
from the recordings folder. Don't you know where it is?
No.
You're in the Google Classroom, right?
Yes, I am.
Go there, please. Go there, please, and then you will. It was at the end initially, I believe. Maybe I put it. Yeah, it's if you go at the end of this, you'll find Meet recordings. You can click it, and then it will take you to A2. You can click and find the date which we did the lecture. Okay, get it?
Okay. Thank
Yesterday
you.
was 7th, so you can please watch that. It's very important. Anyway, so going to the next then. So that's a good. That's not fair. Wait a second, please. I clicked something else. Wait there. Okay. Now, I don't know we have enough time, so I'm going to go to the next page now. If you guys have written, I want to go, please. Okay. So now, experiment to verify Einstein's equation is what you're going to do. So before you draw anything, just wait. I'll tell you when to draw, because then you might have to erase a lot of stuff. You won't like it. Just give me 1 second, please. You can draw the drawing now, this one, and then well, I'm drawing the next piece. Okay. So now start labeling. This is basically a photo cell. These are carefully calibrated filters. This is a micro ammeter. This is variable power supply. This is stopping voltage, and this plate is zinc, and that rod is copper. This is the same photo cell in 3D that you see there, and this is copper rod. This is the zinc plate. Alright, kids. Okay. Once you've drawn this, then I'm gonna go forward. Oh, Huda, you also missed the class yesterday. I just remember. Did you watch the recording?
No, sir, because I had to prepare for the physics exam that I have tomorrow.
Okay. Please do it soon. Okay. Okay. All right, kids. Done. Should I start explaining this to you people? So basically, what happens is that when this UV light falls onto zinc, okay, this is UV that comes from here. So electrons from this plate are ejected towards the copper rod. The copper rod then takes these electrons to the other, to the circuit that is connected like that. Is it clear, everyone? So what I'm saying is that the electrons that are ejected from this enter into this circuit, and they start to move like that. But if you notice, there is a negative terminal of the battery just right where the electrons have entered. Because it acts like a cathode, so the electrons the battery are sending are trying to balance out the ones that are incoming from photoelectric effect. Do you guys understand that? Now we want to stop the fastest moving electron. It could be any electron that comes in. And in order to do that, we keep on changing this, the variable voltage, until we have a zero reading on the microammeter. Microammeter is a very sensitive ammeter. We don't want any current to flow because we want to completely stop the electrons that were emitted due to photoelectric effect. So I'm gonna write this down and you guys can follow along. So we can say light goes and hits the curved surface, and so electrons are ejected from the metal surface right there. Now, the metal surface is skillfully designed so when electrons are released, they are targeted at purposely placed anode collector. This is basically the copper rod that you see in the middle. Alright, kids? Now, the ammeter reading must always be 0. And to do this, we use a regulated variable power supply and thus we are able to change amount of work done by battery such that we stop the fastest moving electrons and ensure current stays 0, just like that. Now kids, this way we can basically see that work done by battery is equal to the maximum kinetic energy of fast moving electrons. All right, kids, any questions here?
No.
Good. Now, obviously, the work done by the battery has to be voltage times the charge it is releasing. And that explains us stopping voltage. Now they're going to ask you the definition of this one. So that's why I put a star on that. That's very important. If they say what is stopping voltage, you're going to say it is the minimum voltage required by regulated power supply to stop moving electrons ejected during photoelectric emission in a photo cell in the completing circuit that you see on top. Okay, just like that. Okay, please write this down. I'll be back in like 2 minutes.
Done.
All right, kids. So now, you guys have written this. Should I go forward, please?
Yes.
Okay. Now we're going to basically learn the math behind this, right? It's very simple. I'm just going to add a page here. It's right. It basically follows the law of conservation of energy. So as you guys can see, that what really is happening to stop these fastest moving electrons is work done by battery has to be equal to the maximum kinetic energy of electrons, right? Now, previously we have learned that work done by battery is voltage times the charge, and max kinetic energy is equal to the energy of photon minus the work function. That is the minimum energy required for an electron to be released.
So why don't you just write it in the form H multiplied by F minus F naught?
I'm going to write that over it. I'm just explaining now. So the work done by the battery will be the stopping voltage times the charge on the electron, and then the HFI, I'm writing Fi for the incident frequency, minus HF naught. F naught is the threshold frequency. Then I'm going to build a graph of it. When I would do that, basically the graph is going to show me, like if I take values at different frequencies, the graph will show me a straight line and a negative intercept, like that. On this side, I will have EV, and on this side, I will have frequency incident. So we keep on changing the frequency, plot the graph. This is 0. So interestingly, if you look at the value EVS, okay, if you look at the value on the y-axis, we have EVS. On the x-axis, we have mx plus c. This is the equation of a straight line with an intercept. Everybody agrees?
Then shouldn't the x-axis be HFI?
No, only Fi. The reason for that is that if you look at on the y-axis, we have this value. On the x-axis, we have this value, which makes our gradient of this line to be h, which is the Planck constant. All right, everyone? And the intercept of this line is going to be hf naught, which is the work function, which is the minimum energy required to basically let the electrons leave from at the surface. This means that this is going to be hf naught. This point is going to be f naught, which is the threshold frequency. And after crossing the threshold frequency, we will have kinetic energy only. So it means from this point onwards, like literally this point onwards, we have, sorry, I should have made that, I should have made this. After this point, we will see photoelectric emission, because that would cross the threshold frequency, and that's why they will have kinetic energy. Is it clear, everyone? Any questions? Please let me know. So they might also give you this equation in paper 6 or paper 5. Sorry, paper 5 or paper 4. So you guys need to realize what represents what in this. So do remember that. Alright, if you have any questions, yes, Aisha, Samir, Abdul Rahman, Huda, everything's clear? Khadija squares?
Yes.
Okay. Abu Bakr, what about you? And Zainab?
Understood.
Good. Good. Javeria, thank you. Alright, so now, before even Einstein proved that photoelectric emission exists, there was another scientist who was called a mad scientist because at that time, when he presented his theory, was not believed by other scientists, and they thought he just wants to um, he's making a stunt.
Basically, they thought he was a lunatic.
Yeah, he tried to tell people about his theory, but then other people thought that he's just pulling up a stunt to just win the Nobel Prize at that time. But later on, when Einstein proved this his theory, so then he was also presented a Nobel Prize after his death. So he was dead at that time, by the
Which
way.
should be impossible considering that Nobel Prizes are only given to living recipients.
Yeah, because his theory is such a big breakthrough in the world that without it, Einstein would have never existed. All right.
I
So
mean, I
his
wouldn't
name,
necessarily call Rosalind Franklin's contribution to X-ray diffraction or Gregor Mendel's genetics theory worthless, but they didn't get the Nobel Prize after their deaths.
you can check. Maybe my information might not be right, but he was actually called a mad scientist at that time. So his name is De Broglie. All right. And basically, he came up with an idea. So he came up with an idea that matter and waves are interrelated. Right. So he said that all waves have a particulate nature. Later on demonstrated. All right. So this is extra information. All right. In the bracket. Later on demonstrated by photoelectric effect. Right. And all matter has a wave behavior. So he believed in wave particle duality. This is what he believed in. All right. So according to him, every mass that moves would have a wavelength, which is a characteristic of a wave. Even you and me would have a wavelength. So he gave this equation which says the wavelength of any mass m is given by the equation lambda equals to h over p, like that. Now let me just explain what these are. This is called de Broglie wavelength. This h is the Planck constant. And this is the momentum of the particle. All right, kids? You can actually expand this equation into lambda equals to h over mv, because mv is basically momentum, and you can call this as the mass of particle, and that would be the velocity of particle. All right, if you guys have any questions, please let me know here. Get it, kids? Okay. Now, he basically tried to demonstrate at that time with the diffraction of an electron. Okay, so let's look at that. Example, an electron beam is shot at a double slit. Now, you guys already know from the previous chapter, through the electron gun, we can create an electron beam. Now, double slit is the same experiment. In AS, you might have done AX equals to lambda D, if you guys remember that, right? At a speed of 60% of speed of light. Okay. Now, you guys need to find the wavelength of electrons. You have the formula right there. If you don't remember, the mass of electron is 9.11 times 10 raised to power minus 31. Speed of light is 3.0 10 raised to power 8. Planck constant is 6.63 times 10 raised to minus 34. While you're doing this, I just want to show you the drawing as well. There was a double slit like that. And then there was the screen.
Basically, the maxima and minima one.
Yes. Maximum, minimum ones. Right. Oh my god. Crazy, huh? It won't let me make it. Chalo, goodbye. This was the screen. And there was an electron beam that was shot at this double slit. So what they saw was that it created the diffraction patterns of maxima and minima, which is a property of a wave. It is not a property of a particle. It was believed at that time like that, right? So this is the double slit. This is the screen. And they saw fringes right there. All right. So what he saw on the screen in the 2D figure was this kind of pattern, where you had a brightest spot at the center and then rings of dark, bright spots and then dark spots and then bright spots. Do you guys get it?
Yes.
Like that. And the thing is that this double slit was made up of graphite film. This was not actually a double slit, just a graphite film. I'm going to explain that in a bit, how he achieved that, okay? So, doing the question then, you want to find the wavelength. Obviously, it is h over mv. The h is 6.63 times 10 raised to minus 34, a constant already given in the exam. Mass is 9.11 times 10 raised to minus 31, and velocity is 0.60 times 0 times 3.0 times 10 raised to 8. When you do this, you end up getting an answer of 4.04 times 10 raised to power minus 12. This is the wavelength of an electron beam or an electron when it is moving at this kind of momentum. Alright kids, do you understand that? In fact, if you find it through Google, you will basically see that this is the wavelength of X-rays, and today we basically generate X-rays through the bombardment of electrons at this speed. Do you guys understand that? So he has done so much, and now I just want to write down. Okay. Sorry, wait. So now just write few lines about it. To achieve this, a grating with spacing of interatomic distances is used, and the spacing between act as slits. So we end up getting a diffraction pattern. So what we're saying is that basically atoms are this. They're arranged like that. So between the two nucleuses, we have a gap, and this is the gap that can cause diffraction. And it is so important because if you change the speed of electrons, when lambda of electrons are approximately equal to the gap A, you will see maximum diffraction. And this is how we are able to find the spacing of or nuclei within a certain material as well. So this is another important point. This idea of de Broglie is called wave particle duality. Alright kids, any questions please let me know. Here I can explain it again. Everything is clear? You guys get it? Right, good. Good, good. So I believe then we are done with this part. Then in the next week we are gonna finish quantum and probably we'll try to cover up most of the nuclear physics as well. And then I'll see you. So have a nice day then.